Mr. Yandel here. We have before you a frictionless air track. This thing is very similar to a hockey game that you might have played before. These two sliders ride on air, so they're completely frictionless when you give them a push. And we're interested in the collision and what happens to the two cars after the collision. So let's watch, see what happens, and then we'll show you some numbers to match this. Okay, you might notice that the car stops, so that means the thing isn't perfectly level, but that's okay for what we're doing. And after taking some measurements, we have some numbers for this thing. Hopefully this board is visible to you. We have all sorts of prayers that this will work. We know it's going to be a fairly cheesy video, but it ought to do the job. So, while Mr. Hofstra plays with the camera, we'll start trying to figure out some numbers for this thing. You notice there was a small block and a large block that were hitting each other. Here are the masses and the velocities before the collision of each block. The initial momentum is pretty easy to get. Remember, P is mv. So all we need is 0.1 times 0.75, and we have 0.075 kilogram meters per second, and yes, I'm out of kilogram meters per second. On the other one, what do we have? We have this is going to be the hard one. V equals mv. We have 0.35 times 0. Grab your calculators. I think it's 0. Kilogram meters per second. So there are the initial momenti before the collision. That's before they ever hit each other. Now we have to get initial kinetic energy. The kinetic energy is 1/2 mv squared. Because this is a little tough to calculate, Mr. Hostler, hiding back behind the camera, is going to give me numbers for these. So what was the initial kinetic energy for the small block?
For the small block, we have 0.028 joules.
Yes, energy is measured in the unit called as joules, after Andre Jules. We love that. Or James Joule, depending on who you think. And how about the other? What did we get?
Well, due to the fact that the initial velocity is 0, that initial kinetic energy will be 0 joules.
0 squared is 0. So we have 0 joules. Now we have the velocities that we get when the two hit and hook together. This is called a completely inelastic collision, since the two objects were together after the collision. So now we have to go to the final momentum, and we're back to the mv again. The mass hasn't changed any, but now we have 0.17 for the velocity. So 0.017. Again, I'm not having even near enough room for this. And then the final momentum over here, we have mv. And I have no idea what this number is going to be. 0.35 times, but I think there may be someone to inform us.
Our momentum is 0.0595 kilogram times meter per second.
So there's that. And now the same thing for kinetic energy. Now we need to use the 0.17 for the velocities. Again, 1/2 mv squared. The masses are the same. And again, we're going to need help from a friend. For the small one, the kinetic energy is?
We get 0.0014 joules.
And?
For the large mass, we get 0.0051 joules.
Now, if we look closely and we pay attention, we should notice that momentum is conserved. The momentum before and after the sum total is the same. And remember, we talked about the idea that conservation of momentum is this very important linchpin in the way the universe works. and it should always be conserved. However, what we do lose is kinetic energy. Some of the energy goes out during the actual collision of the two cars. And if we look at these numbers very closely, we should see that.